All right.
All right. So in the finest DevOps tradition, we changed the order. I hope the pizza was good. There is a bit more beer left, so if you're really quick at the end, you might get yourself another beer. Okay, so the second talk of the evening, somebody who probably needs no introduction, but I'm going to introduce him anyway, especially because it's his birthday today. He made me promise not to make you lot sing happy birthday. Yes, service. Oh. Happy birthday to you. Happy birthday, dear Marc. Happy birthday to you. Dude, I'm so sorry.
Yeah, right. You're so sorry, yeah.
No, I'm not. Okay, so yeah, I've known Marc since 2009. We've run this meetup for a year and a half now, and it's really, really great, despite how stressed we always end up looking. So he's going to talk about service and discovery and Puppet. I feel a little bit bad that we're having a Puppet talk, and everyone's talked about Ansible, and we've got one of the best chef people in the room with us over here, Mandy. Say hi, Mandy. But that's the way it's worked out. Yay! So yeah, Puppet, chef, Ansible, name your poison. We're going to talk about Puppet now. Over to you, Marc.
Cool. All right, thank you, everyone. All this talk could be applied to chef literally, and it would work. So first of all, welcome everyone. I prepared this presentation for Puppet Camp, so expect lots of puppets and stuff like that. So introduction, who I am. I'm an engineer based in London. I co-founded a small company called Chancery with my other half here, that we do consultancy and we do DevOps stuff and Agile stuff and stuff like that. I'm right now contracting in Trainline, so yes, I am trained, pleased to be so. I've been working 19 years as a sysadmin. By my gray hair, you can see I'm old. And I worked in several startups and in some companies that are quite nice, like Canonical and Rackspace. And at Canonical, I co-founded a product called Mass that they are drumming up right now a lot. And I was involved in the creation, well, at least I tried to be involved in the creation of something called Juju, which I must apologize for. I'm very sorry about it. If you experience it, my sincere apologies. At Rackspace, I built a DevOps team, and I've been doing DevOps before it was called DevOps, and it was called WebOps, and people were talking about what it should actually be called for the last 6 years. All right, so a quick show of hands, just because I'd like you to exercise a little bit. Who here has everything in the data center? Literally everything. Raise your hand. All right, 1, 2, 3 guys. Who here has everything in the cloud? All right, and most of you are in between, right? So have stuff in the cloud, stuff here. But the thing is that when you get the sales guy from, let's say, Rackspace, for example, just a random example, he calls you and says, yeah, you can move everything to the cloud. It's cheaper and better and never fails. But the thing is that the cloud, in reality, the cloud is very hard. So your machines start going away, services disrupt, you have network partitions that you wouldn't have in a real data center. Your machines suddenly slow down, they lose CPU cycles, and everything under the sun. So anything and everything can happen to your machines. And one of the things is that most of the people trust the good old DNS to be able to tell where the machines are and where the services are. The problem with that in the cloud is that when you have an environment in which all your servers can go away at any given notice time, or an email from Amazon saying, yeah, we're terminating your instance in 5 minutes, thank you. Then, yeah, exactly, have a nice day. Trying to do all this with old style DNS is a bitch, literally. It's very, very difficult, because even if you set up a very low TTL, maintaining all that is very difficult, and I would say it's futile up to a certain point. And I've seen people struggle with that. Very good engineers struggle trying to maintain their old style DNS so their developers are happy. And one of the things is that monitoring, the way you normally do monitoring in a solid data center, when you do that monitoring in the cloud, instances go and come due to auto-scaling or due to them failing and things like that. So you're monitoring have new machines, have machines removed all the time. And you need to check for more things. Things like the CPU credits that you have if you're using a T2 instance in Amazon, or the amount of bandwidth disposable in your machines and how much are you consuming and stuff like that. And on top of all of that, just because you like configuration management, things like Chef, which is very cool, and Puppet, which is very cool as well, and other things like Ansible, which is very cool. Everything's cool that if you write code, right? All of that needs metadata as well. So you need to define, you start abstracting things, you get all cocky about getting all of these running, and you define all your metadata. So what's the solution? The solution is not like creating Crossrail 2 like these guys, but the actual solution. It's service discovery. And service discovery, it's a thing very close to my heart. I've been using it in Anger for the last year and a half. And it really solved most of the problems. So service discovery is something that if you use anything that can go away at any point in time, or that you actually want that thing to go away at any point in time, is almost required in order to run something insane. It have active health checking. You can dynamically update a list of services. You can even create a DNS service. So for old style guys like me that like DNS a lot and talk about all the RFCs about DNS and how poor Vixie is my hero and stuff like that, it's very good. It's very nice. And it also can be API accessible. So if you have developers that like to access the APIs and start querying stuff, you can do that. So who here doesn't know anything literally about service discovery? Okay, not many. So most of you guys know some stuff. So I will try to go through these slides a bit quicker then. So let's say that you have a service publication service in service discovery. That would be your MySQL server location, or your API for your shopping basket at Sainsbury's location, for example. Just a random example again. And you have all these different microservices and all these different service nodes, instances, Docker containers, CoreOS containers, whatever you want to run. And all of those are reporting to the service publication and saying, yeah, I'm alive, everything's fine, and I'm serving these. In reality, this is a bit more complex. So you have your service nodes. They are running an agent that runs all the health checks for the service discovery mechanism. And each one of the machines have this discovery agent that just runs all these health checks, checks that everything is sane and is running. Then every time that the health check runs, it goes back to the discovery service and say, yeah, this thing still works the way it should be. So the discovery agent just goes ahead and publishes that to the service publication. So every 10 seconds on every whatever you want, all your machines or all your nodes, all your containers that run that service will be checked against that and make certain that that's still healthy, that that's still running the way it should be. And because, of course, you don't trust anything. You don't trust Amazon, you don't trust your network, you don't trust your developers. I don't even trust my dog sometimes. So what you actually do is that I buy another dog to check the first one, so kind of the same. Discovery agents check, all of them check one another in a trust no one policy. So you make certain that all of them are up. So when I discovered all these, I was reading through all of these, and it was pretty amazing. So that was literally my face. I was like, this is amazing. This is the best thing since sliced bread since last year. And just guys remember this face, because that's exactly the face I had, literally. I was amazed by these. So another example, just because I like examples. You have this service called Web that has these random IPs that I invented. And one of the services go down in sub 10 seconds, normally a lot less. That node, that IP will disappear from that service. So how much traffic have you lost? Peanuts, literally. You have lost nothing. And if you even convince your developers, because that's normally the dev in ops, if you convince your developers to actually do things fault tolerant and they actually check things as well, the amount of traffic or data that you lose will be zero, which is a very good place to be. And then when this service or server comes back again, or this container, whatever you want to call it, or a new one, then suddenly everything's amazing again. And again, this face comes back. It's like, wow, I saved the day without doing anything. That's perfect. Give me money now. Thank you. So there's several service discovery solutions on the market. My favorite one, which is the one that I've based this talk on, is Consul, made by HashiCorp, who is run by the guy who invented Vagrant and invented a lot of other things that I really love. And as I said, I really like this guy in a non-sexual way. So CoreOS also has service discovery because, of course, it runs containers very well. So it needs service discovery in order to be able to spin up and down different containers. And Kubernetes as well, because, again, it runs containers, well, kind of, and it has active health check. So it makes certain that every single part is running. And all of this is published already in a slideshow, by the way. So if I go too fast, you can go there, like my presentation, first of all, and then you can proceed to read it. So all of them have different strong things, but most of them, the things that they have in common, is that they publish an API, so you can query the API through RESTful standard ways, make certain that you get all your things in line. And all of them run different kinds of checks. And some of them have a key value stores that are consistent or strongly consistent, which is very good. For Puppet and Chef, all of them support, both Puppet and Chef, have modules on the market for these, which are free and part of the community. So as I said, I just chose Consul because this is pretty much my favorite, and why hide it? I really like it. So what is Consul? It's a service discovery system, which by now should not be a surprise. It does publish all the services through DNS, so it has a DNS agent in every single machine, and through the API as well, if you want to console through RESTful API. It has a key value storage, which is strongly consistent, and it's very good. It supports a lot of data. Right now, it's limited, I think, to something like 30K or 2K or something like that. I can't remember right now. 12K, there you go. 500K. And that's just because, and I do remember this, that's just because some guy thought that it was a very good idea to run S3, literally, on the key value store of Consul. And that's not good. That's why they put the limit. I'm not joking. So it runs health checks both against the node and against different services. And it also has encryption. So if you are in an AWS or in Rackspace or in any other network that is, let's say, controlled by the NSA, then you want to run encryption everywhere and trust no one. The main thing that attracted me about Consul is that the key value storage is strongly consistent. So there's this page that is called Call Me Maybe. It's a blog page that the favorite thing that it does, and it's recommended that if you can just Google it whenever you have internet, not now, and look at it. It has all the different modern solutions of data store on it, and it just kills every single one of them. Go through all the feature lists and say, yeah, it's consistent. No, it's not. It's the replica is sub-second. No, it's not. So it puts all of them on the stress, and it shows you the actual limits of every single one of them. So whenever you use any of them, like Elasticsearch or Cassandra or anything like that, go to this page, check the real limits of that. And I said, Consul was tested here against etcd, which is the solution that CoreOS created. And both of them handled things more or less well. The consistency in etcd wasn't as strong as Consul. Now they fixed it, all being said. But both of them handle sub-second transactions in the same data center in a fashionable manner, which, to be honest, is not bad. So some concepts for Consul. You have your data center. In this case, your data center is a set of machines. You can call it your AWS region, or your cloud provider number one, or your data center in India, whatever you want to call it. It's a set of machines that have very fast network all across, and that can communicate in sub 100 milliseconds. Then you have your nodes, which is every single one of your instances or containers or whatever you want to run, and your services that you run inside those containers or instances or machines. And then you have all the different health checks that Consul can offer. So if you want to install Consul, you need at least 3 servers. And that's not because they like the number 3, it's because the quorum is consistent this way. So if one of them dies, you still have 2 that have at least some version of the truth. For bigger architectures, it's recommended to use 5, just because I said AWS is kind of fragile sometimes. And it's recommended that you don't trust it and you run at least as many servers as you need to ensure consistency. And all of them get the Consul agent. So the Consul agents register themselves up through a Consul server, and then every single agent runs its health checks, declare itself, etc., etc. And all the agents and the servers check one another all the time. Then on top of that, and this is another thing that made me put that silly face, if you have more than one data center, Consul knows the concept of distant data centers, so you can replicate all your metadata also across data centers. It won't be sub-second, it won't be immediate, but it will be fast enough for you not to realize. It has a DNS publisher on port 8600, and it's recommended that you use DNS mask for this. So this is the only line you need in DNS mask to make it work. And then you have in your machine a DNS that you can ask anything, not only to the forwarders, but also the Consul. And the way that the DNS is published, it uses .consul, just because that TLD doesn't exist yet, but it's just a question of time before IANA declares that valid. And then you have your service name and your zone. So let's say that in this case, since I like AWS, and I like things being close to me, I have this in Ireland, and it's EOS1 in Amazon. And I have a service called web, just because I don't have any other service called web in my data center, right? So in this case, it would be web.service.thezone EU-west-1.consul. And you can get all the same information and more, like the port number of the service that you declare, et cetera, through the API. So this is all the API routings. I said you also have health checks. These health checks, there's a small caveat here that I learned the hard way. The checks in Consul are binary. It's 1 or 0. There's no gray. So the service is either running and healthy or it's not running at all. So be very careful with these checks. Make certain that they finish under 10 seconds, which I didn't, and I failed miserably. And make certain that whatever you do, it's a very clear check that does a very clear thing and declares a very clear state. So don't go fancy on those. So in the checks, you have the server check, so you can check the health of your server in general if it has more than one service. And all of those need to pass. If one of them doesn't pass and doesn't pass for a long enough time, your server will be declared invalid. And then the autoscaling will kick, and then you will get a very nice $20,000 bill from Amazon, and you will be declared the hero while not having a job. Then, and this would be the kind of checks, right? The memory, the CPU load, and log check, all the kind of things that you would declare as this machine, in order to be healthy, needs to have these parameters, and these are the basic things I need. Then inside your machines, you can have one service, or more than one service, depending on what kind of school you are in. If you think that there should be just one service per server or per container, or should be more than one, it's up to you, and how big is your credit card as well. Once again, the API, it provides a lot of value. It provides access to the key value store, agent catalog, health checks, the inside section of the node, ACLs as well, and the status of the agent itself. And it's something that I really, really like, because I like to API all the things. So if I could API my dog, I would as well, but she doesn't allow me to. So again, this was done for PuppetCamp, so I need to talk about puppets now, yeah? So I went to PuppetCamp and I thought it was about this, but that's an old joke. So if you want to deploy this using Puppet, I published this on GitHub. It will download Consul, install everything, and it will give you through Vagrant a 4-node setup. 4-node setup. 3 Consul agent, Consul servers, 1 Consul agent with Apache running, so you can test your stuff. So you can integrate these at several levels. I said using Puppet, change Puppet for Chef just because it works exactly the same. There's exactly the same modules available. So there's the Puppet module that installs Consul, made by Kyle Anderson. There's the one that connects with Hiera, which is the Puppet metadata service that I wrote myself. There's also one that you can use if you want to access directly the key value store that is called Venmo Consular. And there's another one to use templates. So Consul has this concept of templates as well that you can populate with values from the key value store directly. And the good thing about this is that I would say in a config management you might run, let's say, Chef, Puppet, or Ansible every n minutes to keep state, every 20 minutes or every 60 minutes. Or if you run in a zero state, you might not run them at all. But still, you need, let's say, a template that needs to be updated. So you can do this with these in under 5-second basis, which is good. In order to install these, you could just run Puppet module install with the name. It will get it from the Forge, and everything will just run very nicely. Then on top of that, you use DNS mask, because I said you want to have your local DNS service and be able to query your local Consul agent from your local DNS service. So you don't have to get out of your machine. You get very quick responses. And then you can start defining your checks. So for example, in this check, I check that I have at least 5% of disk, and that would raise a warning, but that would not kill the node. But if I'm at 1% of the disk, then yes, I will kill the node because, hey, I don't want to run all the way to 0. And you can use this as well to check your services. So you can declare a service healthy or unhealthy by running the health checks. In this case, for example, I'm running Nginx, and I'm just checking that I can actually connect to port 80. There wouldn't be a reason for Nginx not to serve port 80. So I think that's a very valid check. So before I continue, who here uses or knows Puppet, even if you hate it? Okay, that's most of you. Chef, anyone? Yeah. As well. I know you guys use Ansible as well. Nobody uses SaltStack anymore. I don't know why. It's very nice. Hmm? Do you use SaltStack? Ah, there you go. Someone does. But yeah, last time I asked, everybody was trying SaltStack. Now suddenly nobody uses it. But anyway, so if you want to connect your metadata service, which is in this case is Hiera, because I'm running Puppet, you can connect different modules into Hiera, which makes it quite useful. So by default comes with a YAML module, because everybody loves YAML, of course. And then in this case, I can connect it also to my Consul module. So anything that I query through Puppet, any kind of metadata that I need, I will ask plain text YAML files, and then I will ask Consul for it. If you want to install the Consul module, it's the Consul Hiera module, you can just run this. And then if you want to add that to your Hiera configuration, it will look like this. This is not the full configuration, of course, because it's a lot longer. But the important thing is that just make certain that you configure that to connect to your local Consul host, to the port of the API service, and make certain that you connect to the API paths that you want to check. In my case, I just want to check the services and the nodes, and I'll show you why later. So this would be just that area, just so you can read it better, because at PuppetCam, the screen was very small. So one of the good things about this is that I can use this to populate array members. So let's say something like RabbitMQ that you can run in a cluster. There's also a debate if you should run it in a cluster or not, but I'll let you decide that. So in the case you want to run it as a cluster, I don't want to know who are my servers. I don't really care. So I can spin servers up and down on demand. So what I do is that whenever I spin up a new server, all the rest of servers will know about it, because in RabbitMQ, unless somebody invented a plugin in the last month, which I hope not because I look like a fool now, you need to declare all the APs of all the different RabbitMQ nodes in order to do the cluster. Since it requires that, what I did is I just wrote a helper function that queries the Consul key value store, gets every single node that runs RabbitMQ as a service with the service name that I wanted, and declares all of them as a cluster into the configuration. If you want to do something a bit more complex, so somebody here asked about Neo4j before. So Neo4j does the same thing for clusters, but it goes one step further, and it also asks you to declare the port, just because you can change the port number and things like that. So in this case, here's an example of me doing the same thing, but not only getting the IP, but also getting the IP and the port. So whenever I add a new node to Neo4j, I need one or more seed nodes to declare. So I can use these, get as many as I want, feed them to Neo4j, and be happy about it. The good thing about all of these is that since you are connecting to the API, which again I really like, you can configure it to query anything you want. So there's people that have used Consul just to declare all their metadata. They think it's strong enough and it's consistent enough to have all the metadata inside. So you can use this to query the key value store or to query a subkey of the key value store, like for example the /web or things like that. You can even go all the way and use this to configure it by environment. So you can have a leaf key node by environment and do all your different environment changes there, and it will be magically configured. So again, that's how this looks like. Yeah. So all of this is very cool, but one of the things that I normally talk about, because I'm very paranoid about this, is security. So let's say that you're doing all the right things. You are very DevOpsy and you're using GitHub in anger, and you are putting all your infrastructure as code there. Whenever you hire a new guy, or whenever you give a developer access to that, one of the first things that might happen if they don't have enough experience is this. So they go, yep, I'll just write my password in the code because, hey, it should be okay, right? And I'll just commit and push that to Git. So whenever that happens, let's say that, for the example, you have a security officer in your company. They will look like this. And
you've got them a cleaver or X.
Yeah, exactly. So they will be holding some kind of weapon as well. But this is the most scary thing, that face. You don't want to get that face from your security officer. The next thing that will happen, of course, is that you will end up like this. Yeah? You will end up without a job. Nobody else will hire you because you're the guy who published all the passwords to GitHub. So please don't do that. And if you see somebody doing that, let them know that it's not good. So of course I want some security on top of this. Consul is very good. You can do all your key value. It's encrypted all the way. But still, I want to maintain security. So you can use things in order to encrypt things in Hiera, like using Hiera YAML, or Hiera GPG if you like GPG and you're an organization that uses that for public trust and stuff like that. Then your Puppet query chain will look like this. You will ask YAML, YAML, and Consul. In this case, the good thing is that YAML is so good that it supports the Consul as a backend as well. So if the string looks like a thing that it would support, it will decrypt it. You can install here as a gem. With Puppet 4, this has gone a bit weird since they do their own gem install. But anyway, you can do these. Next thing you do, you create the keys. And these keys, of course, you keep them in a safe place. You don't pass them around. You don't take them in USB sticks. You don't publish them on the internet or in a GitHub repo and things like that. Then the next thing you do, of course, because you're very DevOpsy, you read the manual, right? And you run the command to see exactly what it can do. And it can do two different things, I would say, if you want to reduce this. It can pipe something and create an encrypted form, or it can edit a file with your favorite editor, which of course is VI, and you can encrypt values in there. The values unencrypted will look like this. So this is your YAML file with your key, which is my secret, and you will see this deck PKCS7, and with your secret inside, which in this case is my password. And whenever you write that and you want to publish that to GitHub or something similar, it will actually look like this. And that's my password in the encrypted form, which is very good. It's one level of security. It's not that by doing this you have solved all the security forever, but it's a way to avoid publishing your passwords or other important information into public things. So whenever you do that, then the next party in your company, you will be the guy who speaks on the microphone and goes, yeah, I encrypted all the things, I'm great, and I saved the company. But yeah, that's pretty much all you get, because this kind of job is like that. So, extra time. So I added some more slides into this. So one of the things that I really like when I work in a company is to be the superhero. And not like this, because if I was only that, people would just run away, literally in anger. But one of the things that I'm toying a lot right now, because I'm a security guy, in essence, don't quote me on that, is Vault. So Vault is another wonderful thing created by the guys from HashiCorp. I said, I like these guys. It's a way to solve that security conundrum, because one of the things that you have is that you do all the right things. You publish everything in an encrypted form. You have all your uses and passwords for all the different databases, your IAM profiles for accessing Amazon, and all that. But those passwords need to be rotated if you have a good security policy. Or if you don't have a good security policy, they will be the same for 10 years. So it depends on you. But those passwords normally don't change. So Vault kind of solves that. So the thing that you do with Vault is that you don't trust anyone with your secrets. You just give them a user and password that they can be revoked at any point in time. And anytime they need a secret, you can recover that. And it will be recovered either in encrypted form or in non-encrypted form if it's over a trusted channel. And you can create any kind of secrets by doing that, read the secrets, and then destroy them. But the thing that you can do, which really amazed me, is that if you do proper config management, or if you do what it's called a zero-state configuration in which you deploy new machines all the time, things like that, you can actually create temporary credentials. So you don't even trust the applications with the real credentials. So what you do is that you ask Vault to create temporary credentials that will be valid for a certain amount of time, in this case, 1 hour. And you will get those credentials to the application. After 1 hour, the credentials won't be valid anymore. So even if there's anything that goes wrong, that credential will only be valid for that amount of time. And again, that's my face now with this. I'm just amazed by how this works and how secure it is. And that's pretty much me. So any questions you have or any comments, tweet me if you don't like the presentation as well. I'm fine with criticism. So yeah, that's it. So,
any questions for Marc?
No. You're certain? It wasn't that boring, I swear.
Question about Vault. So how the credentials get propagated, for example, for the application? Is it an automated way, or how does it work? Or is it still manual? Or?
So do you mean in Vault or in?
In Vault.
Yeah. So the question is, in Vault, how do you propagate the credentials? So it said if you have proper config management, or you have anything that resembles automatic creation of instances or things like that, or API accesses, then Vault itself will create those temporary credentials for you, because it will know the way. You will tell it, use these credentials that you have securely stored on your very secure location in order to create these. So it's a good way to hide the real credentials, or to limit the access to the real credentials as much as possible.
Any more for any more?
No? Anyone else?
No? Cool. You got off lightly there, Marc. Thank you very much.
Thank you.
Okay, so just a few more things before we wrap up. First of all, the wonderful new London DevOps tradition, it's the paperweights. So I want to thank massively for a brilliant talk and fielding so many of your awkward questions. Thank you, Wojtek.
Oh, wow.
I'm not sure he deserves one, but I'm going to give him one anyway. We didn't have these when I did my talk last year. Marc, thank you. So that's about it. Thanks very much to Sainsbury's folk, to Mike, to Chris Bell, who's running around like a blue-ass fly, organising stuff and getting pizza and beer in, to Jack and Stacey and Sam and the Prism guys. Thank you very much to all you lot. Who have I forgot to thank? Anyone?
think that's it, yeah.
Thank you to me for talking so well. And we're going to go to the City of York pub, which is just up towards Chancery Lane, kind of that way. There's about 7 beers left as well. And thank you most of all to all you lot for coming. Happy Christmas, Happy New Year.